Thank you all for joining us. We'll get started in just a few moments.
Hello and welcome to today's American Nuclear Society Nuclear Nonproliferation Policy Divisions NNPD program Security Aspects of Offshore and Floating Nuclear Power Plants. This field of nuclear is seeing exponential growth for several different applications worldwide and has a lot to promise in the economic growth, but there are many questions that need to be answered. We look at the nuclear security aspects and how we, the non-proliferation and policy community, can contribute. I'm Shikha Prasad, founder and CEO of Sujin LLC and the immediate past chair of the ANS Nuclear Non-Proliferation Policy Division. I'm pleased to represent the division and serve as a moderator for today's event. Please be sure to join the Nuclear Non-Proliferation Policy Division to receive updates about this and similar updates. Before we get started, I'd like to cover a few brief notes. Today's webinar will be structured as 10-minute presentations by each of the 4 panelists, followed by 10 to 15 minutes of Q&A at the very end of the webinar. Many of the speakers have said that they might be able to stay a few minutes later because I know we have a lot of attendees today. So we will go over 15 minutes after the hour when it was scheduled to be over. So if you have time, please stay. If you have any questions, please type them into the Q&A function. Due to the very high number of attendees today, only non-proliferation and nuclear security related questions will be discussed at the end. I will attempt to address as many questions as possible. And there is a possibility that some of these questions will be posted or made available to you, but we will get back on how that will be done later. The event will be recorded and a link to the recording will be emailed to event registrants tomorrow. Additionally, certificates of attendance for the event are available by request. Please see the chat for contact information. A big thank you to Dan Goldberg for organizing this very interesting webinar for ANS and making it so successful. Finally, we ask that all participants adhere to the ANS Code of Ethics and Respectful Behavior Policy, which can be found at ans.org. With those notes out of the way, I'd like to introduce our panelists. I'll go through the introductions for all of them. So we'll begin with Sanjana Shashikumar, who serves as a senior regulatory analyst at Core Power in Washington, D.C. Sanjana specializes in understanding how nuclear technology can support the maritime industry's transition to a low carbon future and works closely with regulatory bodies, including the U.S. Coast Guard and the Nuclear Regulatory Commission. Mark Fialkoff is a nuclear security research staff member with the Transportation Security Engineering and Analysis Group with the Nuclear Non-Proliferation Division at Oak Ridge National Laboratory. Mark serves as a subject matter expert to the International Atomic Energy Agency and member states in the development of transport security regulations and regulatory matters associated with floating nuclear power plants. He also serves as an adjunct professor of law at the University of Tennessee, Knoxville College of Law. Then we'll have Meyer Mamteman, who is a principal engineer with the American Bureau of Shipping. He is a nuclear physicist with more than 15 years of experience in applied physics, radiation detection, nuclear well logging, and advanced reactor systems. As a committee member of the IAEA, he has played a key role in nuclear technology development, isotope production, fast neutron source development, and innovative reactor designs. And last but not least, all the way from London, we have Jess Sims, who is a leading nuclear assurance expert with Lloyd's Register, shaping the regulatory framework for maritime nuclear power. He has a proven track record in complex nuclear facilities. Jez uh, has technical experience, which has made him a pivotal figure in initiating the International Maritime Organization's revision of Safety of Life at Sea, as you may know as SOLAS, Chapter 8, having co-produced the foundational gap analysis for the World Nuclear Transport Institute. His industry leadership continues in his role as the chair of the International Association of Classification Societies Nuclear Project Team, where he is instrumental in defining how classifications can support the safe integration of nuclear technology into the maritime sector. Thank you so much, speakers, for all the time you have dedicated to this. Sanjana, thank you for joining us. I'll hand it over to you to kick off the presentations. Thank you.
Apologies, I'm having some technical difficulties. Okay. Thank you so much for that introduction, Shika, and to Dan and the ANS Nuclear Nonproliferation Policy Division for having me. Good morning or afternoon. As Shika said, my name is Sanjana. I'm a senior regulatory analyst with the team at Core Power. Our company is working to deploy advanced nuclear technologies in marine environments. And today I'll be discussing nuclear power and the importance of security frameworks to support their developments at sea. A brief introduction to Core Power. So our company is partnering with various reactor developers to build and deploy the first complete end-to-end maritime civil nuclear program. With the world facing increasing energy demand and looking for cost-competitive solutions that also meet decarbonization goals, we see advanced nuclear as the necessary catalyst that can transform and how and where energy is delivered, specifically to this crucial industry. So we're working on two specific applications, the first being floating nuclear power plants. FNPPs are nuclear power plants permanently mounted onto non-self-propelled barges to produce energy. So they allow for mobile energy to be deployed where it's demanded, in contrast to traditional terrestrial reactors. In this model, the power plants are manufactured at a central facility that's responsible for that manufacturing, distribution, servicing, refurbishing, refueling, and decommissioning of the reactor and barge. It's expected that the barge will have an operational lifetime of approximately 30 years. And depending on the reactor technology utilized, the reactor will be refueled or replaced every 5 to 10 years. So this design supports serial deployment of floating assets in which the reactor is replaced or refurbished and the barge can continue to be utilized. So from that central facility, the FNPP would be transported to a pre-approved licensed site for operation. We see various potential applications, both near shore and offshore for FNPPs, and I've highlighted a few of them here. So in the nearshore environment, FNPPs are sited close to shore to provide power to coastal infrastructure, such as powering port operations. This is currently how operational floating nuclear power plants and other non-nuclear power barges are utilized. The proximity to shore reduces distances between the source of power and the end user, reducing transmission, construction, installation, and infrastructure costs. Alternatively, the offshore deployment model sites FNPPs further from shore, similar to offshore wind farms on the outer continental shelf. This reduces their exposure to tsunamis and earthquakes while providing power to offshore energy users, such as data centers, oil rigs, and e-fuel production facilities. The second application we're developing are nuclear propelled vessels. So this application is not new. In addition to nuclear navies, you may be familiar with the nuclear ship Savannah. It was a commercial nuclear powered ship that sailed during the 60s and 70s that transported passengers and cargo and visited over 70 ports. It was part of President Eisenhower's Atoms for Peace movement. That being said, today we are designing vessels that utilize advanced reactors instead of PWRs that solve some of the scalability and cost challenges faced with the development in the 70s, that still maintain safety and the ability to be commercially insurable. So nuclear powered vessels are attractive to the maritime industry because they offer zero emission operation and support the meeting of these strict greenhouse gas emission requirements that have come through from the international organizations, and still can transport cargo at fast speeds with less time dedicated to refueling compared to traditional fuels. So the production of nuclear powered vessels would follow a similar design to that FNPP central facility. The central shipyard for nuclear propelled vessels would be responsible for that manufacturing, fueling, refueling, servicing, and decommissioning of the reactor and vessel at the end of its lifetime. So to understand how to specifically address nuclear security, which is our conversation today, I'm going to walk us through some deployment models and then discuss some of the important considerations that Core Power is taking and how we're incorporating those into this phase of development. So this first scenario is specific to FNPPs. Here, it is built and transported to the operating site without any radioactive material. The fresh fuel is independently transported, and it is commissioned at that operating site. The fueling, this type of shipment is widely practiced, as you all know. It's how terrestrial reactors are fueled, and it was utilized for the commissioning of the currently operational floating nuclear power plant, the Russian academic Lomonosov. So after the academic Lomonosov was constructed, its two unfueled reactors on board were transported to Murmansk, where it was commissioned. So the second scenario is also specifically addresses FNPPs, particularly at the beginning of the life cycle. So here, the FNPP would be loaded with fresh fuel at that central facility before it's transported to the operating site, which of course, there's a predetermined time frame and it is licensed to operate at that location. Finally, this scenario here accounts for the transportation models that Core Power specifically is exploring, in which the spent fuel is stored on the FNPP or vessel throughout the duration of the life cycle. So for FNPPs, the reactor is commissioned at the central facility before being transported. During the transport, the reactor is subcritical, but throughout the various stages of the life cycle, and for the entirety of the ship's life cycle, a nuclear powered ship, the used fuel is transported on board, either in the reactor or in a spent fuel pool, from that central facility to operating sites or in between various ports for transportation. So now that you have a better understanding of what these deployments look like, this sets the stage for our discussion today on the importance of security regimes for floating nuclear applications. So it's important to know that this framework development will require coordination across International Regulatory Commission, given they're the primary lead for the enforcement of nuclear security requirements for commercial facilities in the United States. Central to our approach at Core Power has been that with nuclear security has been understanding and differentiating between boundaries, barriers, and the controlled versus uncontrolled spaces, and then establishing the appropriate protocols and security measures to restrict access between these defined spaces. So these protocols would be maintained throughout the entire operational and decommissioning lifetime, and will also be constantly monitored to understand changes in potential threats, therefore allowing the necessary adjustments in capability and performance of security programs. So with advanced reactors and this application currently under development, we're already identifying and incorporating design features today that can mitigate threats and risks when these are deployed, such as multiple containment structures and fuel type design. So before I conclude, I wanted to share this. Core Power was a founding member of the Nuclear Energy Maritime Organization. Now it has over 50 members, and I would not be surprised if many of you today are part of organizations affiliated with NEMO. I bring this up because NEMO has NGO status at the IAEA and the IMO, which is the International Maritime Organization, and are leading conversations to develop the necessary frameworks to support nuclear mobility. Specifically, they are hosting a workshop in October, specifically targeted to security by design. And both the IAEA and the IMO are participating and presenting in this workshop. So I'm happy to share more details if anyone's interested, but I bring it up because it demonstrates that there is active involvement from these international organizations in this topic to help support this deployment. So I'll conclude with this. FNPPs and nuclear powered ships are under active development and address unique and pressing challenges in the maritime industry. Although there's no specific framework in place that addresses security-specific considerations, there are these significant efforts underway by various stakeholders to support this deployment that is expected within the next 5 years. So thank you so much.
Thank you so much, Sanjay. I really appreciate it. It was a very interesting presentation, laying the groundwork. Now, with that, I'd like to request Mark, please come back on, and we look forward to your presentation. Mark from Oak Ridge National Labs. Thank you.
Thanks, Shika. I'm just waiting for my camera to turn on. And thank you, Dan. As my camera is turning on, I'd like to thank ANS and welcome everyone to this webinar. I'm going to be talking about a question that I get as part of my work on floating nuclear power plant security. Can a floating nuclear power plant be attacked by a pirate, and what does that look like, primarily from the law side? And so this is some ongoing work sponsored by Oak Ridge National Laboratory, looking at what does piracy look like for floating nuclear power plants, particularly on the high seas. And before I proceed, I'd also like to acknowledge my co-colleague who is working with me on this project, Mr. Cody Havelak, who I'm not sure if he's on today, but has been participating in this research. So with that, next slide, please. So and Sanjana did a great job of talking about and introducing the concept of floating nuclear power plants, but one of the primary challenges in the international community right now is, what is a floating nuclear power plant? Is it a piece of cargo that you put on a heavy lift ship or that you tow? Is it a vessel? Is it treated similar to an icebreaker? Is it a facility? And we have these different terms and definitions that really range not just between IMO, maritime law, and nuclear law, but also within nuclear security, I think nuclear safety, nuclear safeguards. We're trying to, with ongoing efforts at the IAEA, trying to really discern what is a floating nuclear power plant. And the reason is, especially for security, it's important that we are using the correct physical protection measures, whether it's material in transport or it's a facility operating offshore, making sure that the physical protection measures are appropriate and that they are calibrated to any, for example, design basis threat or threat assessment that would be associated. So understanding what it is really still I'll say, an open question, or one that is one for discussion still. Dan, next slide, please. So this is a little bit of a crude representation, but one of the questions that comes up with floating nuclear power plants, especially in the literature and in international conferences, is what is the threat for a floating nuclear power plant from an act of piracy, especially when the FNPP is maybe in transit on the high seas or operating on the high seas. Sanjana pointed out in her presentation that floating nuclear power plants could be deployed offshore for oil and gas extraction. So if they are in the high seas operating and there's a pirate ship nearby, this is a little, again, crude icon, is it susceptible to piracy? And what we start to look for is the international framework for not just nuclear security, which is governed primarily by the Convention on the Physical Protection of Nuclear Material, but for us, we also have to look at UNCLOS, the UN Convention on the Law of the Sea. And UNCLOS does give a definition for piracy. And I will not read the whole definition of piracy, but for our purposes, what we're interested in is, first, the individual, the pirate, is conducting his action for private ends. And this becomes a challenge and has been written about and documented, the difference between a pirate and a terrorist, and what type of legal framework is appropriate for criminalization and adjudication. It has to be on the high seas. One of the elements of Article 101 of UNCLOS is that piracy is on the high seas. Now, piracy can occur elsewhere in other parts of either the territorial waters or the exclusive economic zone. But for UNCLOS purposes, they've zeroed in on the high seas. And for our discussion, it has to be ship to ship or vessel to vessel. Um, Similar to what I discussed before with nuclear law, maritime law has not done a service to itself in that there is no unified definition to what is a vessel. We have some guidance from SOLAS, but UNCLOS does not provide a definition to a vessel. Dan, next slide, please. So in our scenario, if we're looking at a floating nuclear power plant that's operating um, on the high seas but is not moving, it is, for all intents and purposes, considered a facility. Now, where I come with this approach is outside of nuclear security, the IAEA has begun to look at floating nuclear power plants from a third-party nuclear liability perspective, and have started to try to provide guidance for how FNPP should be treated when they are in transport versus in operation. And from at least the liability side, their initial recommendation is that it's a facility. So now we have a question of if pirates were to board, does the Brown Gangplank, the floating nuclear power plant, well, we don't have a vessel to vessel movement. We have pirates potentially boarding from a vessel onto a floating nuclear power plant. But if piracy is not potentially an applicable crime, what are we looking for? What are some of the other international frameworks that we can be latching on to and that are important, especially for nuclear security of floating nuclear power plants? Next slide, please. So here I say in the absence of the law of the sea, and maybe that's a little bit too strong, but we also have nuclear security instruments, starting with the amended Convention on Physical Protection of Nuclear Material, that lays out crimes against nuclear material for nuclear security. We're concerned about theft and sabotage, as well as illicit trafficking of nuclear material. So the convention, the amended convention, requires state parties to develop a legal and regulatory framework to account for um, these crimes. In addition, we also have ICSANT, the International Convention for the Suppression of Acts Against Nuclear Terrorism, which also seeks to criminalize this type of behavior. Now, it's not piracy per se, but it would fall under crime that ICSANT prescribes. And very similarly, we have the SUA protocol that lays out crimes for either attacking vessels or infrastructure on the high seas, especially in the protocol speaking about nuclear and radioactive material being on board or on the high seas. So there is a, I'll say, constellation of other nuclear security frameworks in place to help to ensure that while piracy might not be an applicable crime, there are other frameworks in place. And where we also look to is within the IAEA guidance, the nuclear security series, because one of the questions that comes up is, well, what do we do on the high seas? Isn't this somewhat the Wild West when it comes to nuclear security or maritime security? And we actually look to Nuclear Security Series 13, also known as InfoCirc 225 Revision 5, where it talks about the role of the flag state. So if an FNPP is potentially flagged, that criminal framework, so sabotage and theft, would apply in the absence of piracy. But we run into challenges. Dan, next slide. I think there's one more slide. Yeah, there we are. we're really, especially when we compare the UN Convention of the Law of the Sea versus the amended convention, we see differences, especially with things such as universal jurisdiction under UNCLOS and ongoing efforts at universalization of the other agreements. And so when we think about nuclear security, we're really dealing with and trying to understand when a floating nuclear power plant is operating in these either remote locations or locations that raise novel jurisdictional questions, how do we make sure that the material is protected, not just the physical protection measures, but also making sure that if there were acts against the floating nuclear power plant, whether it was theft, sabotage, or anything else, states parties had appropriate recourse to deal with such actions. So with that, I think that is my last slide, and I'd like to say thank you.
Thank you so much, Mark. Appreciate it. And I request the speakers and all the speakers here, if you're able to answer any of the questions in the Q&A, go ahead and do so. Some of them are quick ones. And with now, Meyer, I welcome you to present. Meyer from ABS. Thank you.
Well, just putting up my presentation. Just give me 1 second.
I will request the attendees, though now we have close to 600 attendees. Can you all please submit questions that are more related to nuclear security, because those will be the ones we will be answering in this webinar. That will help us keep focused. Thank you.
Okay, is my presentation visible?
Yes. Looks good.
Okay, perfect. Greetings, Ines. My name is Meyer Mantuman. Great to be here discussing nuclear security of the floating nuclear power plants. We have heard really interesting talks from Sanjana and Mark. I thought I would bring the perspective of classification society with regarding to nuclear security from the regulatory perspective. So is that? So just a quick introduction of what is classification society. Classification societies are, they serve as independent arbitrators of standards. Their mission is to promote the security of life and property and preserve the natural environment. This mission is achieved by establishing and administering standards known as rules and requirements for maritime vessels and structures from their design, construction, and operational maintenance point of view. Other than rule development, classification societies also provide certification, survey and inspection, statutory service, and as well as research and development. Some aspects of this has been already discussed earlier by Sanjana, but just to reiterate, this is ABS's view on the future of nuclear maritime market. As you can see, at the middle of that, I wonder if I can put. So if you look at the floating nuclear power plant, providing power to either to the grid onshore or electricity to offshore industry, or even some type of alternative fuel manufacturing facilities, production facilities. On the bottom, you can also see a nuclear powered ship, but this is not part of this discussion. But overall, this is what we see the future might hold in terms of floating nuclear power plant. A quick look back on the history of ABS nuclear rules. ABS had guide for the classification of nuclear ships, and this guide was used to class the U.S. NS Savannah, as mentioned earlier. which is one of the earliest commercial nuclear-propelled ship. Although this guide has been retired, currently we do not have So going to the next slide here, we published a first of its kind nuclear power systems for marine and offshore applications in 2024. This is applicable for all kinds of nuclear power, floating nuclear power plants. And in order to get the class, it's a mandatory power service nuclear notation. And this requirement is written such that it's suitable for any type of nuclear technology. So it's agnostic of the type of reactor or the nuclear technology is being used. And one of the unique parts of this ABS requirements for nuclear power systems, we introduced first of its kind a document called interface document, where most of the stakeholders between marine and nuclear industries overlap, and the regulatory gaps are identified in this interface document. So just a bit more on this interface document. As you can see, this is a simple depiction of a floating nuclear power plant and all the subsystems that the nuclear subsystems as well as the maritime subsystems and the interaction between them. This interface document mainly tries to establish the technical agreement among the stakeholders and tries to establish the regulatory overlaps or even gaps between different regulatory bodies, from nuclear regulatory bodies as well as maritime regulatory societies. So looking at this FMPP requirement of ABS, I thought I would go ahead and look at all the considerations or discussions of the nuclear safety. So I populated this slide looking at the FMPP. So the FMPP is written mainly using this philosophy called goal-based standards for nuclear security. So the goal-based standards focus on the desired outcome instead of a prescriptive process to achieve that desired outcome. It often comes with a functional requirement that that system must follow to achieve these goals. So in our FMPP requirement, the nuclear security is addressed by starting with risk assessment, where the hazards and the associated risks are addressed. And it also introduces risk reduction measures to mitigate effects. On the next section, nuclear systems, the nuclear security is also a key part of it, from a structural, radiation, physical security, nuclear material security, and all the way to decommissioning, waste handling, and operational safety. The section on the machinery, electrical, and piping equipments, special considerations were given for nuclear security as well, for maintaining the security, to provide that means to that, and the hull design and arrangement, as well as radiological protection and nuclear material handling. Last but not least, we have a specific section for controlling, monitoring, and system safety, specifically surrounded around the nuclear safety systems the access control, radiation monitoring zones. Is it a restricted zone, or what type of access levels are given to minimize the risk of radiation as well as the proliferation risks. From the ABS FMPP requirement document, another thing that I did was try to pull out all the phases of the FMPP life cycle that the nuclear security is addressed. So roughly, we can look at this 7 different life cycle phases. Again, these are under development, and some of the systems are not quite the same as these life cycle. But it starts with design phase, where the security by design is embedded. Then the next phase could be the vessel construction, where the interface document comes in very handy for different stakeholders. The next phase could be the nuclear system installation phase. As Sanjana mentioned earlier, this is again being developed and fleshed out. Transportation and commissioning, either before fresh fuel is installed or after fresh fuel is installed. This is a key part of concern that needs to be addressed for nuclear security. The operational phase, where the FMPP is positioned and providing power. Now we have the maintenance and the refueling phase, either for the inspection, dry dock inspection, refueling, or just the regular maintenance phase. And at the end, it would be either decommissioning, retiring of this vessel, with transportation or without. So in summary, I just like to summarize with the note that the nuclear security is at the heart of maritime regulatory process, as well as the classification society is trying to understand and address as it develops. As presented, nuclear security are integrated throughout the regulatory framework and the life cycle considerations. And with that, I would like to conclude. Thank you.
Great. Thank you so much, Meyer. Appreciate it. That was a very interesting discussion. So now we have our last speaker, who is Jez Sims. Jez, please take it away. Thank you.
Thank you. Good afternoon, or good morning, everybody. Apologies, I'm just getting over a bit of a cold. My name is Jez Sims, and I'm the Nuclear Technical Authority at Lloyd's Register. And I would like to thank Shiko and Dan and everybody at ANS for the opportunity to speak today. As Maya mentioned previously, Lloyd's Register is also a classification society, and for over 260 years has been synonymous with maritime safety and excellence. It all began in a London coffee house in 1760, and the mission was simple yet revolutionary: to provide reliable, independent information on the quality and conditions of ships, allowing insurers and merchants to manage their risks effectively. Today, LR's role as a world-leading classification society is more crucial than ever. It sets the standards and ensures ships and offshore assets are safe, sustainable, and fit for purpose. This is especially vital as we explore complex technologies like maritime nuclear power. Today, I'm going to outline LR's robust integration framework designed to guide the licensing, classification, and security management of new nuclear maritime assets. We'll explore how this approach ensures security is not an afterthought, but a foundational component from the very beginning, providing a clear and defensible safety and security case for these critical assets. The move towards nuclear power in maritime has been a significant step forward. but it introduces unique security challenges. We're not just talking about traditional maritime security. We're dealing with the need to protect nuclear materials and technology against sabotage, theft, and unauthorized access. Whether it's a nuclear-powered container ship on a global route or a floating nuclear power plant in international waters, each scenario brings its own threat profile. Project teams must therefore develop specific security strategies, and our framework is designed to provide the structure for doing just that. To meet this challenge, we have developed a robust integration framework. It's aligned to the IAEA core principles of safety, security, and safeguards by design. This philosophy mandates that we stop treating security as a siloed function. Instead, security considerations, threat assessments, and protection systems are integral to the verification process at every concept and project stage. This isn't about adding security features on at the end. It's about making informed design and project choices from day one to mitigate threats proactively. By doing this, we can create a holistic, graded approach that aligns perfectly to the IEA's International Standards 3S model, ensuring the safety, security, and safeguarding are given equal and integrated consideration. You will see that we've got a 7-stage integration framework: the interface definition, detailed integration, installation oversight, testing and commissioning, operational assessment, in-service validation, and decontamination and decommissioning. And as Maya did previously, I've aligned some of the some of the security elements, deliverables that should be looked to be completed at each stage. These presentations will be available afterwards, so people can get a good read of these after. So what does this look like in practice? Our framework structures the security system around several key components. First, it starts with the enabling security elements. This is a human and organizational foundation. You cannot have effective technological systems without a strong security culture, competent personnel, and resilient organizational structures. This is a key component of our approach. Next is the physical protection systems, or PPS. This is about preventing physical threats. The key principle here is defense in depth, using multiple layered barriers and systems to deter, detect, delay, and defeat any potential threats. The framework allows novel solutions, including the use of innovative detection technologies to assess threats quickly and establish secure protocols for critical operations, such as docking operations, ensuring there are no weak links in the chain. As maritime digitizes, the cyber domain is a critical front. The requirement for cutting-edge cyber protection systems, or CPS, that are designed to deliver robust cybersecurity for all data, IT, and operational technology that is vital to the maritime nuclear assets' safe and secure operation is paramount. This involves conducting specific vulnerability assessments for maritime nuclear operations, using strong encryption and tightly controlled access to sensitive information. This might include solutions such as establishing rapid response teams to handle any cyber incidents. Finally, we address the human element directly through insider threat mitigation. An insider with legitimate access can pose a significant risk. Our framework sets goals that require comprehensive vetting processes, continuous monitoring for security concerns, and behavioral analysis to spot anomalies. This is supported by regular training to reinforce the strong security culture across all personnel. And whilst our integrated framework provides the essential structure, executing it to the highest standard demands collaboration with the best in the field. That is why we collaborated with Global Nuclear Security Partners, or GNSP. They are a world-leading UK-based consultancy who have shaped nuclear security regulation and best practice both here in the UK and globally. Crucially, their expertise mirrors the holistic nature of our framework, providing specialist support across the cyber, physical, and human domains we've just outlined. This partnership ensures that our integrated security plan is not only robust in theory, but is also informed by cutting-edge real-world experience. By embedding the integrated framework into the safety case, the benefits are clear. We move from a reactive security posture to a proactive one, designing out vulnerabilities before they can be exploited. This structured approach provides a clear, traceable pathway to validate that the asset is protected against the proposed full spectrum of physical and cyber threats. It gives project teams, operators, and regulators the confidence that security has been rigorously and holistically addressed throughout the asset's entire lifecycle. This is the foundation for a complete and defensible security case. So in summary, I'd like to conclude that our integrated framework provides a comprehensive structure needed to manage the complex security demands of nuclear maritime assets. By adopting a security by design philosophy, we ensure that security is a non-negotiable foundational pillar of any nuclear maritime project. I thank you for your time today, and I'm happy to answer any questions that you may have.
Thank you, Jez. Really appreciate that very comprehensive and thorough presentation and for staying on time. All speakers, please come online with your videos turned on. I will start with the Q&A and try to keep it focused on nuclear security in the interest of time. We will factor about 30 minutes for the Q&A. If you have to leave on the hour, that's fine. Go ahead and do so. All right, so let's start with the first question. What is your anticipated enrichment level for 5 to 10 years of refueling? And what might be the staff size, including security staff, operating, and maintenance on board? Anyone who wants to take a first go, please go ahead.
So I'll jump in on this one. So I think it would be fair to say that all of the proposed technologies use a low enriched uranium. Now, whether that's below 5%, as is currently the use in civil nuclear, or whether we're looking at high assay low enriched uranium at the sort of 5 to 20% is to be determined. And Mark knows well from listening to me speak, the anticipated enrichment level for a 5 to 10 year refueling will very much depend, and that's the key word in this, it all depends on the application, the use of the technology, the size of the technology, and effectively what you're going to do with it, because a high temperature gas reactor and a molten salt reactor fueled and used entirely differently will have different recycling durations. So it's not an easy question to answer with a specific answer, but I would expect they will be fueled sufficiently to enable the refueling period to align to the classification docking requirements or the requirements for inspection and survey for dockings, such that they can be refueled in the relevantly licensed dry dock, and that they would be able to maintain or meet their power requirements for that duration.
Great, thank you, Jez. And I kind of vaguely remember having read somewhere that the academic Lomonosov may have, which is about 4 years recycling, I think has close to 20% enrichment, and Mark may have more information on that as well. So
yeah, I think it's about 18.6. It's either 18.6 or 19.2, but I don't know off the top of my head.
Great, thank you. All right. Okay, if there are no more comments on this question, let's go ahead with the second question. Has academic Lomonosov made port calls outside of Russia? If so, what was the international reaction? Has the ship sold energy or only demonstrated the capability to produce and transfer energy onshore? What security safeguard measures has Russia agreed to regarding their floating reactor program?
So I could jump in and talk a little bit about where the academic Lomonosov has been. So as I mentioned, it completed construction in St. Petersburg and was transported to Murmansk for that initial fueling. After that, fueling and commissioning. After that, it was tugged, my memory is about 4,000 miles to Pevek, which is in the eastern part of Russia, and it is currently providing power there to in Pevek. My understanding is that the academic Lomonosov and the Russian nuclear-powered icebreakers have not left Russian jurisdiction. So again, there may be another panelist who can correct me if I'm wrong.
Thank you for that clarification, Sanjana.
I'd like to just add one thing here, and I think Sanjana made a good point. One of the challenges that we're going to run into in nuclear security, especially with the transport of loaded floating nuclear power plants, whether they are going out loaded with fresh fuel or coming back with irradiated spent fuel, depending on how that's done, either on board or if it's taken to an INF vessel, is we have to remember the principles of international transport and making sure if it goes near transit states, those transit states are aware, notified, and that those transports are being done in alignment with their national frameworks. It's one of the, I'll say, fundamental principles of the CPPNM and the amendment is international transport and ensuring physical protection. Both the CPPNM and the underlying transport security guidance documents really call out the need for the transit states to be either involved through notification and or making sure transport security plans and other documents are maintained and respected for those transits.
Right. And in both these cases, are you anticipating that the fuel handling will be done pretty much in territorial waters, like the 12 miles, nautical miles, or it could be even outside of that?
So I'm going to say it depends, but I'll pass to to other panelists.
Okay.
So-
If there are no, yeah, go ahead.
I was just going to say, so in the model that I discussed, the fuel handling is happening at that central facility. So when the FNPP is commissioned, and the fuel is loaded at that central facility, it's transported, it's operating, it comes back, and the fuel handling again is happening at that facility. Fuel is not handled at the operational site in the models that we are currently looking at.
Yeah, that definitely sounds a lot more secure.
So that central facility is responsible for that, the license to handle nuclear materials, and it would need to be for every location at which FNPPs are deployed.
Great. Thank you, Sanjana. All right. Well, the next question is, physical security is understandably unique for FNPPs. Are there any unique cybersecurity concerns? So this was talked about in Jez's discussion as well. And how are they, cybersecurity concerns, being addressed? Any further comments?
So I wouldn't say there's any specific, cybersecurity is a concern of all organizations that have, a vulnerability, embedded into their software. I think it's what it does is it makes the probabilities of remote operation far more challenging than having localized operation with perhaps remote monitoring. Any chance of anybody being able to through cyber attack take control of a nuclear installation or facility is obviously something we very much want to avoid. So unless we can show with very clear certainty that is not going to happen, I would imagine it would preclude the remote operation for now.
Right.
But yeah, but obviously being able to demonstrate to the regulatory bodies, and just as important is being able to demonstrate to the public for public awareness and confidence that these systems are robust and secure, it is very important.
Okay, so you're precluding the autonomous vessels, if you will, from this.
I mean, I wouldn't preclude anything. However, I would imagine that it's going to be prohibitively hard to be able to demonstrate that currently.
Sure, makes sense. All right. Okay, so with that, the next question is an issue is who and where do the used fuel become processed? We worked with Russia on the EBRD funded decommissioned in Murmansk. What is intended for the interim transfer for floating reactor to be used, floating reactor to the used facility? What is intended for the interim transfer from floating reactor to the used fuel facility?
So I'll just jump in on this one. So I don't. So a lot of these questions are incredibly good questions, and they're very much the questions that the industry is already asking itself. We don't have a lot of certainty around some of the answers, and again, I keep saying it depends, but I think it will depend on the technology choice and the application of that technology. Some deployable nuclear maritime reactors may refuel in a very similar way to how civil reactors currently refuel. They will be done in a licensed dockyard in the same way to how defense assets are currently refueled. And that spent nuclear fuel or that high-level nuclear waste will be transported to either an interim or a high-level storage facility in the same way that civil nuclear material currently is. There are other suggestions from developers and reactor vendors that specifically, or more at the smaller end of the scale, the sort of micro reactor end of the scale, where you will have maybe one or multiple of these micro reactors. You'll use them for their design life, and then what you'll effectively, this is how they've got the sort of notation of battery reactors, is you'll take one out, put a new one in. That's effectively the recycling or the refueling, and then the used one then sits for a period of time for the decayed products to reduce, and then it's transported back to the reactor vendor, where they effectively reuse that micro reactor, refuel it on site, manage the disposal of the fuel, and then send it back out again as a new, a renewed option.
Great. That's a fantastic design to be explored and developed. Thank you, Jez. Any other comments from any other speakers? Okay, so now we have a scenario question. A floating nuclear power plant transits through the Red Sea and the Strait of Hormuz. What kind of military and legal protection would such a ship facility expect to have? Some or greater than a very large crude carrier, VLCC. If such a floating nuclear power plant is hijacked, will this be considered an act of proliferation? If a VLCC is hijacked, will it be considered an act of proliferation?
Well, so I'll start. I don't think in the anytime near future we're going to see nuclear assets deployed in the Red Sea or the Straits of Hormuz. Yes, obviously they're going to have increased security and the sort of safeguards around those assets. It would be, I imagine, from an insurance and liabilities perspective, that would preclude the operation of those assets in those areas. We very much foresee, certainly to begin with, these assets will operate in defined corridors or in safe transit routes. We've seen the Russians using them as nuclear icebreakers. The northern passages seem to be a viable option. Anywhere where there is significant conflict, I would not expect to see a nuclear-powered ship or offshore unit.
Great.
I would jump onto that if we have time. I think one thing to take a step back from, and Jez, and I think Myers mentioned this, is the role of the design basis threat, and what does a design basis threat look like for a floating nuclear power plant? Because how do you develop, especially if they're being developed in serial production at shipyards and dry docks and being transferred or exported? I think, Jez, you mentioned security by design. How do you build security by design into that construction process when it can be going to different threat, either high threat areas, low threat areas? So I think there almost has to be, I'll say, a step back of what does a design basis threat or threat assessment process look like for a floating nuclear power plant, maybe even agnostic of, I think the example was Strait of Hormuz and the Red Sea, which, as a colleague of mine would say, that's a really extreme, even though, present day scenario. Do we have such tools in our toolbox so far? Do we need to be thinking about that?
Yeah.
Great.
So actually, I completely agree. As you know, the design basis threat is a very sovereign-based capability requirement. It's intrinsic to each national requirements, their own threat profile, and how they perceive and the threat against civil nuclear. As you know, we don't have a maritime DBT. That needs to be looked at. That's something that NEMO and Atlas from the IEA are going to look at. And I suspect, Mark, you're right. I think what we'll probably end up having to do, because we are going to need serial production of these assets, is we're going to have a baseline requirement, and then there will probably have to be an operational deployment threat analysis for where we're going to use these assets. That would have to be, dare I say it, something that we'll have to consider after the integration of the nuclear asset.
Great. Well, thank you for giving that challenge to us to develop a solid maritime DBT scenario framework as well. I think that's something we'd be, as a community, the non-proliferation ANS community would be interested in. So any other comments to that question? Okay, so Mark, actually the next question is for you. Why, they're asking, why wouldn't the nautical rules of the road definition of a vessel prevail? Every description of watercraft, including non-displacement craft, wig craft, and seaplanes used or capable of being used as a means of transportation on water. So they're wondering about that definition.
And this is something, and I think Sanjana spoke a little bit about this in her slide, or had a slide about sort of the evolution of this at the IMO. You're trying to look at international agreements. So we're looking at not just, I'll say, the nuclear instruments that maybe the non-pro division is used to with safeguards and security, but now we're pulled into maritime law. And so we're really looking at one of the base documents, SOLAS. And when you look at, and I'm trying to do this off the top of my head, I think it's Regulation 3. It says that vessels have to be under some sort of, I think, mechanical propulsion. And so most recently, I know the IMO has undergone discussion about changes to SOLAS Chapter 8 and how that's looked at. But to the question, trying to I don't want to say jam, but push different definitions in will create some, I would say, not disharmony, but discontinuity with but especially maritime law and especially the nuclear law as you're trying to synchronize those. I'll give a good example that I sometimes use in my law classes. In the United States, we're still trying to figure out what a vessel is. And I think the last Supreme Court case dealt with literally a boat with French doors and like a fully developed kitchen is whether or not this houseboat is a vessel. And so this is a really, I would say, challenging question that there is no unfortunate straightforward answer. I don't know, Sanjana or Jez, if you want to jump in on the IMO discussions ongoing.
Oh, I was actually just going to jump in on how you were saying it's impacting in the United States. This definition also impacts other ways that these are going to be regulated outside of nuclear security. So that disharmonization would have other significant impacts. So it is important to get those definitions clear and get that understanding clear. So that like was mentioned earlier, we interface a lot with the United States Coast Guard, who also has vested interest in understanding if these will be regulated as vessels or facilities, etc. So
yeah, I just add on to that. So you're absolutely right, Mark. So it's the Safety Convention MSC 110 in July this year, the IMO approved the review and update of SOLAS Chapter 8, which is the nuclear shipping code, and specifically Resolution A491, which is a code of safety for nuclear merchant ships. The key part of that obviously being nuclear merchant ships. The Russian delegation wanted to add in rules for FMPPs, for floating nuclear power plants. So clearly there is a need to be able to define what is a floating nuclear power plant and what is a ship within these regulations, such that people do understand exactly what is and what isn't covered by the regulations.
Great, thank you for that. So the next question is a more broad one. What lessons are we learning from the US Navy and their security and safety systems? Has anything been made public? There's a lot to be learned from them as well.
So I'll jump in on this one. So I think there's a lot we can learn from both the US Navy, the UK Navy, any of the navies that have nuclear defense assets, because these are deployable nuclear assets in the maritime environment. So there are obviously lessons that we can take. I think we need to be careful about recognizing the requirements that defense has over a commercial civilian operation, merchant shipping. And I think it's also clear to recognize that defense assets are highly enriched uranium cores in PWRs. They're not going to be low enriched uranium, and they're not either generation 3+ or generation 4 currently reactors. I very much think to get to a place where we have the mass-produced fleet model adoption of these nuclear assets, such that we can deploy them in an economic and financially viable way, we're going to very much have to take a graded approach to the regulation and deployment of these assets. We can't regulate them in the same way that we do large civil nuclear or even defense nuclear. So there's a lot we can learn, but we need to really be working towards providing the requirements in a graded approach for these assets.
Great. Thank you for answering that. To all speakers, how shall we approach, from a design point of view, the objective of harmonization between safety and security, and more generally, including cybersecurity, when talking about the use of nuclear energy and the objective of 3S by design? So this is security, safeguards, and safety together by design.
So I'll jump in because I think it actually, in the maritime case, becomes a little bit more complex, because you have safety, security, and safeguards on the nuclear, but you also have maritime safety and maritime security. I think as Jez and Mayer talked about, I was in 2023, the IAEA had a floating nuclear power plant symposium. And during that meeting, one of the questions was, from a design perspective, whether it's a floating nuclear, well, we were talking floating nuclear power plants. Someone said, as a marine safety person, I want to make sure people can egress and get out of the structure if, God forbid, there was a marine safety event. Okay, now I have to compare that with nuclear security, which says I need barriers and delays and 8 levels like Sanjana had in her 8 squares. So now we're almost playing, I won't say 4-dimensional chess, but now you're almost looking at this not just in a 3S, but it's like 3S plus 2M, and trying to, I think, balance that. I'll say up front, I don't necessarily have the answer to that, but I think part of what will be interesting and is exciting in this space is, what does the construction and design process look like? Is there opportunity in the shipyards and the dry docks and these construction facilities to have those balances and trade-offs? But I think there's an almost increased complexity, because now you're not just in the nuclear side of the house, but marrying nuclear and maritime.
Absolutely. Thank you so much, Mark. The next question is a little specific, and I'll merge 2 questions. My question would be threat vectors from underwater sabotage, i.e. closed loop scuba divers, placing mines and explosive torpedo attacks, etc. How would you address that? And I would I'll add another question. Someone asked about hull engineering and how they can save against these threats. So if the speakers can address, that would be great.
So I'll give you my opinion on this. So I think, again, so this speaks to we need to look at the probability, the credibility of the threats. We can all postulate situations and scenarios well beyond design basis accidents that could or may happen. I think what we need to do is we need to look at the credible, likely events, and then be able to demonstrate, which I think maritime already does. If you look at some of the accidents that we've had at sea recently, a collision of 2 ships in the North Sea off the coast of the east coast of England, that was one at anchor and one at speed, and it effectively T-boned it. There was a significant amount of damage, but both were floating and were recoverable. So even an incident like that demonstrates the survivability and the integrity of these assets already, and that's without even taking any design considerations for the application of nuclear to these assets. We've already got double-hulled ships, so there's already a lot of evidence there to suggest that we're already designing ships probably close to the standard that we'd need for maritime nuclear. It's just a case of identifying what we need to do to secure them, the probabilities and the likelihood of these scenarios, and then being able to demonstrate that we've provided the sufficient security protections to safeguard against them.
Right, great. So the initiating, so if you were to do a probabilistic risk analysis or something like that, you would have your initiating event as the collision that you described, which I think it's interesting, but that seems to be more probable, the ship accident than, I'm not being biased, I hope, but then the nuclear threats and the probabilities associated with those events. Okay, all right. So next question is that would creating an international scheme of nuclear vessel regulation through the IAEA be more practical than at the national level? This might make it easier to determine challenges in security and regulatory processes.
So I'll jump in here. In some ways, that already exists. And actually, it's under the IMO through the INF code. And I was going to piggyback on something Jez said. In some of the scenarios that were discussed, some of this is already faced by transport. When we've been transporting nuclear material by sea 60 some odd years, but this is some of the considerations. The challenge with an international framework is, and I'm coming from a law perspective, I will say, oh no, not another treaty. Because, trying to write a treaty takes a lot of time. Trying to develop a treaty and get everyone to essentially buy in on the treaty can be a challenge. We saw as a good example with the INF code, it first was voluntary and then became mandatory. One of the questions is, can we work within existing frameworks? For example, we know that the CPPNM and the amendment speak to very broadly nuclear security of nuclear material. So whether that's a floating nuclear power plant or material in transport on a floating nuclear power plant, security is at play. There is a legal and regulatory framework at play. Does it present novel challenges? Sure, but I don't think there's an insufficiency within the framework. One of the I'll say problems is there, and this goes back to 2022, when the IAEA had a nuclear law conference. There was a session on nuclear maritime interface. And the IAEA, one of the experts said, well, we have it all figured out. It's maritime law's fault. And that's not really a fair thing, because it's not the maritime lawyer's fault. It's not the nuclear lawyer's fault. So I think trying to create a new treaty, a new scheme, or a new framework takes away from existing frameworks that have worked and are working. Are there challenges? Yes. But I think that's where the nuclear security series, IMO guidance documents can support strengthening those regimes rather than trying to create new ones.
Absolutely. Yeah, we have to work together to strengthen each other. Absolutely.
Yeah, I'll just
comment?
add to that so quickly. I know we're short on time. I think that's certainly something that the Atlas project that the IAEA have announced that they're going to start very soon is something that would look at. And I just to touch on what Mark said, the likelihood of these attacks, if you wanted to attack, if the intention of blowing up a nuclear ship is to cause as much damage and spread as much radiation as you wouldn't attack a nuclear ship. You would attack a ship carrying nuclear spent fuel, because the amount of radioactive product they carry is infinitely more, and therefore would be a much more viable target. And we've been transporting nuclear materials at sea for decades.
Great. Thank you, Jez. And with that, as a question for you, actually, how does Lloyd's Register work with industry developers to implement the integrated framework into their design process? So I would focus on the security aspect here.
Yeah, so as I said, we've got partners that can support us in the security aspects, GNSP specifically. And it's a case of working with all the stakeholders. And part of the project delivery at the beginning, the concept design, is understanding that stakeholder matrix and understanding who and what, which regulatory bodies, which flag states, which national authorities, which industry partners you need to work with. And then it'd be a case of using the framework as a tool to develop the safety kit, the integrated safety case that supports the project deliverables.
Great, thank you. And I'll ask the last question now, and that is, in high seas, extremely offshore FNPPs, how is the delay time being modeled when the response time is going to be at minimum hours versus the conventional much shorter response time that we experience in power plants. So they're wondering about the longer response times in case of a nuclear a security incident at sea, as opposed to a much shorter time if it was a land-based reactor. Then you've got people that are coming in right away to respond in very short amount of times.
Well, I'll jump in. I think one of the questions that comes from this is, what is the physical protection system? So not just the detection and the delay, but also the response. So when an FNPP is going to be deployed offshore, there would be at least some initial consideration of what is this response going to look like? Do you have some response on the FNPP? Do you have nearby? But I also think one of the things to consider also is, especially when we're dealing with transboundary issues, going back into the convention and realizing the role of international assistance and cooperation. So I think that, yes, there are challenges. I know MIT has done research on understanding different standoff distances for a hypothetical offshore floating nuclear power plant on their design. But I think even before we get to, is it going to be longer, is understanding what is the planning and how is that taken into account in those planning stages way before the deployment stages. Not saying it's going to be minutes, but I do think that there would be greater accounting for that in both the planning and the security plan itself, even a potential contingency plan.
Great. Well, thank you, Mark. And with that, thank you all for giving your time to this very interesting webinar, close to 600 attendees. I am sorry to those attendees whose questions I couldn't answer, but please keep in mind, we are trying to find ways to post these questions online, and you might be able to find an answer to your question if it wasn't answered just right now. Okay, well, thank you so much, everybody. And you hopefully will have a great day forward. Enjoy the day. Thank you.